I'm going to use this rod to fish for fireflies. It's the actual rod used by the scientist who was the first to decipher the various call signs of fireflies. And there are 15 different species, at least, around here, each with its own signal. Biologist Jim Lloyd used the rod to imitate male fireflies and so decode their various light patterns. He discovered that the call sign consisted partly in the actual flight path of the species concerned. There are, for example, some fireflies which move steadily horizontally like that, and there are others which turn their light on as they climb, like that. But in addition to the flight path, they flash a particular signal. It's rather like Morse code. So I should be able to use this light myself. There's a female amongst these leaves here which will emit a single flash, and the male of her species waits for precisely 4 seconds and then answers back with a flash, whereupon she immediately gives another flash, like that. And the male then knows that he's going to be a welcome visitor. But the message has recently been shown to be more than a simple signal for sex. A female judges the quality of a male's genes by the precision of his timing and the brightness of his light. She encourages her chosen suitor by directing her lanterns towards him. And it seems this male sent out all the right signals. We are now discovering that this language of light even has local dialects. Throughout the summer months, from Florida to southern Canada, gardens, fields and forests sparkle with these mating messages. Time-lapse photography reveals the extraordinary extent of this courtship. Some species flash only at dusk. Others prefer the forest canopy for their light show. Some species make their flashes more conspicuous by choosing the very darkest places in which to display. I can see virtually nothing here except the flashes. And this particular species has another trick too. It synchronizes the displays. Individuals flash together. Each individual is triggered by its neighbour, and soon waves of light pulse through the woods. Speeded up, the wave becomes clearer. Between the waves, an impressed female can respond with 2 flashes of her own. And the males home in on her. But she can only choose one. These displays peak for just a few nights in June, which could explain why they were only recently discovered. Why they all flash together is still a mystery.
Some insects have gone even further. At the base of a sheltered cliff, the sand is pockmarked with tiny pits. This moonscape of craters is the work of the larvae of ant lions. Antlion larvae vibrate their bodies to dig into loose sand. Then, by moving in a small circle, they slowly create a conical pit. The larva then buries itself at the bottom of the pit to wait for its unsuspecting victim. The steep slopes of loose sand are a lethal trap, almost impossible for the ant to climb out. And the larva uses its head to flick sand at the ant, knocking it down to the bottom of the pit again and into the jaws hidden just below the surface.
Thousands of bees working in perfect harmony until there is a threat from the outside. A giant hornet, a killer, 5 times bigger than any bee, able to kill with a single bite. But this hornet is not here to attack, but to seek information. Information he can take back to his own colony. This small gang of predators have taken over an abandoned burrow on the other side of the forest. Using an advanced form of chemical communication, the scout passes on details of the exact location of the honeybee's nest and leads them back to the hive. The bee colony is an important source of food for the hornets. The bees shake in unison to warn off the enemy. But the hornets don't stop. They hunt for ways to break into the hive. Just a few hornets can exterminate an entire colony of bees in a few hours. First, they tackle the guard bees. They are after the protein-rich larvae inside. Individual bees have no chance against the hornets. And the hornets are too heavily armored for any bee sting to be effective. The bees are picked off one by one. The colony is almost defeated. But it's not over yet. The bees have not given up. The fight back has begun. The bees' stings can't kill the hornets. But they do weaken them. As their attackers retreat, the bees unleash their secret weapon on the last remaining enemy. They work together, paralyzing the hornet. Creating a ball. And then the bees vibrate, raising the temperature at the center to a level the hornet cannot withstand, cooking it alive. The bees have developed this unique defense over millennia. Millennia which have seen this battle fought again and again.
Dragonflies are more powerful and agile in the air than damselflies, and they defend their own territories around lakes and ponds, engaging rivals in aerial dogfights. But this intruder is a female, and the male dragonfly finally realizes this. So he now grabs her and hooks up in midair. Now they must perform the same gymnastics as damselflies. They can even fly, locked together like this. But after mating, they separate, and the female goes off to find somewhere to lay eggs on her own. She lays her eggs inside plants, but she's very choosy about picking exactly the right place. The carefully tended lilies in this ornamental pond are just right. Sometimes, in her quest to give her eggs the best chance of survival, she decides that the perfect place is a long way below the surface of the water. But she doesn't mind getting wet. A dragonfly can tell a lot about both water quality and the submerged vegetation from the way that polarized light is reflected from the surface. So, although the whole pond looks the same to us, discerning emperors quickly home in on the most suitable spots. And one egg-laying female soon attracts others. An egg-laying emperor is noticed by the local common blues that also use the pond. But why? Are they just curious about these lumbering monsters? Possibly. But back on the big lake, where there are vast swarms of common blues, this behavior seems to be much more than just curiosity. As soon as the female emperor lands on floating vegetation to lay her eggs, she's surrounded by clouds of common blues, buzzing her, mobbing her, harassing her, even landing on her and biting. Eventually, it all gets too much for the female emperor, and she gives up. Why do the common blues risk their lives chasing a dragonfly that is much bigger than them and could easily kill them? Probably because of what those emperor eggs will become. Eggs hatch into larvae, and emperor larvae are killers. Lethal predators. Damselfly larvae are right up there at the top of their menu. Those sharp eyes spot any movement. And the emperor larva stalks its lunch like a tiny cat. Its eyes are huge, and both face forward. So the larva has a stereo vision. It can judge its distance from a target very precisely. And when it's close enough, it deploys its secret weapon. Jaws that can shoot out an additional half-length of its body, a long-range strike capability that, for the damselfly larva, comes out of nowhere. The jaws snap shut, and the damselfly is impaled on sharp spines, to be hauled in and chopped up by a pair of serrated blades before being swallowed. It's hardly surprising that emperors and common blues don't get along with one another. But don't feel too sorry for the damsels. They also are killers and use the same tricks as the bigger dragons, just on smaller prey.
The weaver ants march with their prey, flying termites, in a funeral-like cortege. A ceremony with a macabre end. The lives of these termites were short, but their bodies will not go to waste. One of the forest's most efficient predators. Weaver ants pass information between themselves as they track down their lifeless prey, ensuring their troops work with ruthless efficiency. This ant seems to be lost, as though he didn't get the memo. However, looks can be deceptive. This is no ant, but a perfectly formed, ant-mimicking spider. 2 legs project forward, disguised as antennae. Black patches mimic ants' eyes and draw attention away from her own. The perfectly honed disguise. By comparison, this male appears a little clumsy. Seemingly carrying a smaller ant on his front. But this is a killer detail in his costume. A mask for the long, sword-like fangs, crucial for fighting off his rivals. The stakes are high. The prize is mating rights with the nearby female. The battle over, his jaws close, and he resumes his pretense once more. He's more than happy to pick on someone his own size, but needs his disguise in place to avoid taking on someone even more vicious. A jumping spider stalks across the forest floor. Smaller than a penny, she isn't careless enough to take on an army. Besides, it's not ants she's after. Insects are sometimes on the menu, but this is also a spider-eat-spider world. Which means a disguise is a worthwhile investment. Allowing the mimics to concentrate on other matters. Having fended off his rival, this male mimic gets to mate. Using specially adapted mouth parts, he fertilizes her eggs. In this dog-eat-dog, spider-eat-spider world, the struggle to survive has driven the extreme evolution that defines Sri Lanka's forests.
Mosquitoes breed in Miami by the billions. They're a mix of natives and newcomers, nearly 50 species in all. Male mosquitoes feed on nectar, but females, they're out for blood. In a single meal, a female can drink 2 to 3 times her body weight. She needs blood to produce eggs. But feeding on humans is risky business. The females that escape search for water to lay their eggs. When the eggs hatch, the hunter becomes the hunted. Mosquito fish. These tiny predators patrol waterways all over the city. Mosquito fish have been introduced around the world to control mosquitoes. But here in Miami, they are native. And they do their work with ruthless efficiency.
Most spiders are not what you'd call sociable. In fact, they're usually downright hostile toward their own kind. But here in the rainforest, there are exceptions to that rule. Spiders that share big communal nests. Now, if you don't like spiders, you might not like this species. It's called Anelosomus eximius. It's harmless to humans, but where you find one of these spiders, you'll likely find a lot of them. They're social spiders, a rare breed. Out of nearly 40,000 spider species, only a couple of dozen do this. Their tangled, three-dimensional nests can be more than 6 meters across and house 10,000 residents. 90% of them are females. The smaller males don't contribute much. It's the females that do all the work, tending each other's egg sacs, looking after the spiderlings, and building and maintaining their home. Here in the rainforest, it can rain really hard. And that can wreck any spider's web. Repairing the damage is easier when you have lots of willing workers to pitch in. That's what makes it possible to live in a big house made of silk in a rainy climate. But this animal house is more than a home. It's also a hunting ground. From the top of their nest, the spiders cast sticky lines of silk that drift on the breeze to catch on nearby vegetation. That creates a trap that can bring a flying insect to a dead halt. When the spiders feel a wiggle on the lines, they investigate. After subduing their prey with a dose of venom and bundling it up in silk, they cart it down to the nest for a communal feast. Tropical rainforests are home to some very large insects. Since social spiders can build enormous traps and overwhelm their prey by strength of numbers, they're perfectly positioned to take advantage of this resource.
In summer, insects are everywhere. Hidden at the top of this old oak is a stag beetle, searching for a mate. But he has a rival. Each is armed with massive jaws, used like the antlers of a deer to wrestle for supremacy. The object is to throw your rival to the ground, 10 meters below, leaving the way clear for the winner. At last, victory. And to the victor, the spoils. A chance to mate and contribute to the next generation of stag beetles. And off to find another mate, or another rival. At the height of the summer, the world is filling with new life.
Thank you for watching. Did you like this video? Tell us in the comments, and please like, share, and subscribe to the Terra channel. Until next time.